which I wanted to discuss. Here the figure is already given, so it is written in the given figure xy and x dash y dash are two parallel tangents to a circle with center O and another tangent AB with point of contact C intersecting xy at A and x dash y dash at B. Prove that angle AOB is 90 degree. Okay, let me draw the figure, then it will make sense that what exactly is given over here. Just a second. Okay, this type of figure is given. It's already there. The figure is there in your book. Okay, you don't need to think about it, how we'll be drawing the figure. Let's see what the question says. Okay, so in the given figure, xy and x dash y dash are two parallel tangent. You can see we are having two straight lines xy and x dash y dash. These two are parallel line and these two are tangent also, which we can see in the figure. Okay, P is the point of contact, Q is the point of contact. We can already see in the figure. Okay, now with a center O and another tangent AB, another tangent AB. That means AB, this AB is also a tangent. Okay, it is clearly visible in the figure also. If you will see the actual figure in the book, you will find that yeah, AB is also a tangent. Okay, where the point of contact is C. Okay, intersecting xy at A and x dash y dash at B. So this AB tangent, AB which is a tangent, it is intersecting xy at A, and the AB which is a tangent, it is intersecting x dash y dash at B. That's what is written in the question. Now prove that angle AOB is 90 degree. Angle AOB, this complete angle we have to show that it is 90 degree. Okay, you can see a triangle type of structure over here. This angle we have to show that this much is of course 90 degree. How we'll be showing it? Any idea? Anyone? Angle AOB we have to prove that is 90 degree. I'm showing the figure. Think about it. If we will drop, if we will join the radius over here, this OC, can we say this will be 90 degree over here?
Yeah.
And similarly, this OP is also 90 degree and here OQ is also 90 degree, right?
Yeah.
Please, this must be. Now, if we will focus on this triangle, and this triangle, is it possible to say that these two triangles are congruent with each other?
Yes.
First, here 90, here 90. Okay, common side we are having, which looks like a hypotenuse. And what else? OP, this is the radius. Okay, and OC, of course, radius. So yeah,
AP and AC will be equal to 1.
uh, yeah, AP and AC will also be equal. So which congruency criteria is working over here?
SAS.
Yeah, SAS. Okay, side, angle, side. Yeah, or you can say all the three sides are same, so side, side, side. Whatever congruency you are saying, at least these two are congruent with each other, right? What will it help showing that the middle, the triangle is 90 degree? So okay, this, if these two are congruent with each other, then this angle and this angle will be same, right? By CPCT, of course, right?
Yeah.
Similarly, we will focus on the other two. Okay, we will not prove. We will say that this pair will also be congruent with each other. Okay, directly we can say, of course, it will be. Okay, this one and the other one, which is just beside the same, the adjacent triangle, this one. This two, of course, it will be congruent. Similarly, we can write it. That means this angle and this angle will be same. And we can say sum of all the angles will be 180 degree because we are having a PQ, which is a straight line. Okay, diameter we are having PQ. So suppose this is y, x, then this is also x. And from here, are we getting x plus y is 90 degree? Yes or no? Y plus x plus x
Yes.
all together are making 180 degree because it's a straight line. That means 2y plus 2x is 180 degree. That means x plus y is 90 degree, right?
Yes.
Right. And that's what we wanted to show, that here the angle is 90 degree. We have divided it and we are saying this much is y, we are saying this much is x. So whatever we wanted to show, we ended up getting, right?
Yes. Yeah.
Everyone is getting it.
Yes. Yes.
Okay, Zanab
Yes.
is getting, Maha is getting. Aisha, Ibad, Fazan, Calvin, are you getting it?
Yes, ma'am.
Yes.
Yes.
Okay, so let me write. Here we are talking about triangle POA and triangle this AOC. Okay, whatever congruency, side congruency, side congruency, whatever you want, you can use it. Okay, doesn't matter. So yeah, let's say AP is equals to AC. Tangent drawn from external point are equal in length. Tangent from and external point are equal. Okay. Now we can say that OP is equals to here OC. Okay. Radius of the circle. And what else? 90 degree, 90 degree. Or another side, there is a common side also. That is OA. OA is the common side. Whatever you want to use it. And say these two are congruent. Okay. So triangle POA and AOC. Let me check the sequence of the name. AP and AC. Yeah. OP, OC, OP, OC. Yes, OA, OA. No, the name which I have written over here, the name is not correct. Let me write it in a proper way. See, at the top, you can write the name anyway. It is completely okay. But when you are using the congruency sign, you should be specific. So, triangle POA is congruent with triangle. Is it, if I'll write like this, will it work? Let me check. OPOC. Yes. OA. Yeah. Okay. POA is congruent with COA. Why it is very important? Because on the basis of the name, I'm going to say that angle O over here and angle O over here. Now it will be same by CPCT. Okay. So let's write it here. Please write the which congruency criteria we have used. So side criteria we have used. Now we'll be saying angle O over here by CPCT, of course. Okay. You can say that these two are X. Let's assume. Okay. Similarly, we'll be writing. Similarly, we'll be writing that QOB and this COB, this two will be same. Okay. Similarly, triangle QOB will be congruent with triangle. Let me check the proper sequence over here. It will be COB over here. Okay. And on the basis of this, we can say hence angle O over here, angle O over there will be equal. That means angle QOB will be equals to angle COB. Both, let's say it is Y. Okay. Let's say. And right here by CPCT, we have written this one. Okay. Now we can say, now since, see carefully, POQ. POQ is the diameter of the circle. Okay. It's a straight line. POQ is diameter of the circle. Therefore X plus X, rather than X, let's write the proper name first. Let's write the proper name, that angle POA plus AOC, angle POA plus angle AOC plus angle COB plus angle BOQ. COB plus angle BOQ all added together will make 180 degree, of course, because it's a straight line. Okay, 180 degree. Linear pairs you can write. Now we'll say that X plus Y plus Y is equals to 180. Therefore, from here to X plus 2Y is 180. And therefore, X plus Y is 90 degree. And hence we are done. Hence, angle AOB, this complete angle is 90 degree. If you want, you can write it this way. AOC plus COB is 90. AOC plus COB is 90. Therefore, angle AOB is 90 degree. Is it crystal clear to all of you what we are doing over here?
Yes.
Now this one you will be telling me how to do it. Prove that the parallelogram circumscribing a circle is a rhombus. Okay, figure is not given, but it's fine. A parallelogram we are having ABCD. Okay, it is circumscribing a circle. Maybe it looks like this. Okay, we have to say that, we have to prove that this parallelogram is a rhombus. Okay, you all know that rhombus is a parallelogram, right?
Yeah.
Okay, rhombus is a parallelogram, rectangle is a parallelogram, square is a parallelogram. These all the three polygons came from parallelogram family. Okay, so yes, rhombus is a parallelogram. Now, how we'll be proving over here that this parallelogram ABCD, it's a rhombus. What is the property of rhombus? Anyone?
All sides are equal.
All sides are equal, of course. Okay, so AB, BC, CD, DA. If we can prove that, yes, in this parallelogram, all sides are equal, then we can say, yeah, it's a rhombus. Okay, how to prove it that all sides are equal?
We can use the theorem.
Yes, which theorem?
It's like a point extended from a circle one. Can we use that?
Point extended from circle. Can you tell me the complete theorem?
It was something like if like there's a point extended from a circle to the circumference or like tip of the circle, it gives two equal tangents. I think it was something like that.
Can we use
Ma'am,
the
in a ma'am, in a rhombus, all the sides will be equal, right?
yeah.
So like we can use that circles property where it said like a uh, tangents is coming from an exterior point will be equal. So like half of AB will be like this much, and so half of AD and half of AB will be equal.
Hmm.
In that same way, half of BA and half of BC will be equal. In that way, you can prove that all the sides are equal. Yeah, that's what I
Exactly.
was saying, but I didn't know the exact word to say.
Yes, exactly. You both are correct. Okay. So yes, can you recall? We have proved this theorem that AB plus CD is equals to AD plus BC by saying that from external point. Okay. Suppose this is R. Suppose let me name it RS. Suppose this is Q, this is P. Okay, the point of contacts I am naming it. So this type of quadrilateral we are having, and we have proved that AR is equals to AS, right? From external point A, the similarly from the external point B, this BR and BQ will be same length. Okay, similarly from the external point C, this length of the tangent, that is CQ, and this CP, it is P. Okay, so CP is equals to CQ. Similarly from the external point D, the length of the tangent, this DP and DS, it will be equal, right? I'm talking about this two length. Everyone, are you getting it? This
Yes.
length and this length. Okay, so at first we'll be showing this one. At first we will show this one. So we will say that dp is equals to ds, and when you will add all the equation 1 plus 2 plus 3 plus 4, okay, 1 plus 2 plus 3 equation number 3 and equation number 4, you will be getting, see this side, AR we are having, and then BR. AR, BR added together will make AB, which I have written over here. Okay. Similarly, CP, DP added together will make CD, which I have written over here. So everyone getting it till here?
Yes.
Yes. First, please confirm. Then I'll be explaining the next part. Aisha, are you getting it, Aisha? Fazan, Galvin,
Yes.
yes or no? Shall I explain it again, or we can move ahead? Yes, Fazan, are you getting? Galvin,
Yes. Yes, ma'am.
getting it, or shall I explain it again?
Getting it, ma'am.
Okay, so we are done till here. Now we can say, since ABCD is a parallelogram, since ABCD is a parallelogram, so opposite sides are parallel and equal with each other, right? Okay, we know that AB will be equals to CD, AD will be equals to BC. Let's write it. We know that AB will be equals to CD and AD will be equals to BC. Now here let's substitute. Here AB is there, CD also we can write as a AB. So basically AB plus AB, okay, is equals to this, you can say equation number 5. Okay, we are substituting this parallelograms property in equation number 5. Okay, similarly AD is equals to BC. Here also you can substitute this, either AD as a BC or BC as a AD plus AD, you can do whatever you want. Okay, either you can make AD plus AD or you can make BC plus BC. Whatever we want, we'll be getting it, don't worry. Okay, so I'm writing it is nothing but just AD plus AD. That means 2AB is equals to 2AD. That means AB is equals to AD. Check it. AB and AD are what? See, we have already proved that adjacent sides are equal in length. This AB is equals to AD. Okay, and already it was parallelogram where AB was equals to CD. So AB was equals to CD, AB is equals to AD. That means we can say that all sides are same length, right? Right?
Yes.
Okay. Yes. You can say from here that AB is equals to AD means AB, BC, CD, AD all are equal length. Hence the given parallelogram is a rhombus. That's it. And one theorem I had left in one of the class. We'll be finishing it today and we'll be moving ahead. But before moving ahead, first please confirm me that till here the first theorem, the first question and this one, both are clear to everyone.
Yes.
Clear. Aisha, is it clear? Galvin?
Yes, ma'am.
Okay, let's move. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. Okay, let's see what the theorem says. figure and anything, just the theorem is given over here, we have to prove it. So let's draw the figure. Prove that, what we have to prove? Prove that the perpendicular at the point of contact. Okay, so let's say we are having a circle. Let's say we are having a tangent. Okay, and this is the tangent AB. We can clearly see that this is the point of contact over here, P. Now the theorem says that, question says that, prove that the perpendicular at the point of contact. If you will drop a perpendicular at a point of contact, okay, if you will drop a perpendicular at a point of contact, okay, that means let's say we have dropped the perpendicular at a point of contact. The perpendicular is, let's name it NP, okay. NP is perpendicular to this tangent AB. Okay, at point of contact, we have just drawn a perpendicular which is written in the statement. Okay, perpendicular at point of contact, we just tried dropping a perpendicular at the point of contact. That's it. What the next part says, it says that perpendicular at the point of contact to the tangent, of course, tangent we are having, and then only we are having the point of contact, passes through the center. We have to show that this perpendicular which we have dropped, this is passing through the center. Okay. So NP is a perpendicular. So first try understanding it, then I'm writing everything properly. Okay. NP is a perpendicular on this tangent AB. We have just dropped a perpendicular. We have to prove over here that this perpendicular is passing through the center of the circle. That's what we have to prove. Okay. So NP is a perpendicular on this tangent AB, which is not here. NP doesn't pass through center. We are assuming that it is a perpendicular which we have dropped, but it doesn't passes through center. A contradiction we are taking. Okay, it doesn't passes through the center. At point of contact to the tangent, we have dropped the perpendicular, and we are saying that whatever perpendicular we have dropped, that is not passing through the center. Okay, it is not passing through the center. Now we will say that there is a center O over here. Okay, that OP, this, the first theorem. I'm going to write the first theorem now. Okay, what was the theorem? I'm writing the first theorem. At any point of the circle, is perpendicular to the radius at the point of contact. Forget about the previous story, everything, whatever we have taken the assumption, whatever we are having in hand, just keep it aside for a while. Okay, keep it aside for a while. We are having a circle, and we are having the same tangent AB. Okay, same tangent AB we are having, and we are saying that according to the first theorem, this theorem which I have written over here, here the proper statement will be through the point of contact. Okay, this theorem you already know. According to this theorem, we can say that here is a point O, and OP is perpendicular to AB. Can we say that by this theorem? Can we say this much? Yes or no?
Yes.
Yes.
Okay. So this is one of the condition. And according to the given theorem, already one assumption we have taken that NP is perpendicular to AB. From both the condition, can we say that this NP is passes through O? Can we say that these two are different line, which is not possible. It is not possible that NP, this complete angle is also 90 degree, and then in the next condition we are saying that this much, of course it is 90. So this is not possible, right? Right.
Yes.
Now we are going to say, but it is not possible that NP is also perpendicular to AB and OP is also perpendicular to AB. Hence, the perpendicular which we have dropped must passes through the center. Am I making sense to all of you?
Yes, ma'am.
Yes.
Everyone getting it?
Yes.
Yes.
Yes, Maha, Zanab, are you getting it?
Yes.
Yes.
Okay. So I'm going to write over here. NP perpendicular to AB and OP perpendicular to AB is not, NP and OP both are perpendiculars, which is not possible. Hence, the theorem, the statement I am going to copy paste. Hence, from here, the perpendicular at the point of contact to the tangent to a circle passes through the center. Or at first, let's write it. Hence, NP must passes through the center O. Hence proved. This is how we'll be proving it. Okay, it's very simple. Just the logic which we are giving can be confusing, that we are saying this also, we are saying that also, but see, that is the only way we are having, because it is so straightforward. Just the statement we will be writing, that we know that we are having one theorem and that is justifying. But that way we can't say, we will be taking the just the contradiction, we'll be saying, yeah, we are having a perpendicular, but the theorem says this is the perpendicular, both can't be perpendicular, hence the theorem. Clear?
Yes.
Yes.
So yeah, you can copy it. Okay, I was telling that I'll be explaining first and then we'll be writing in the rough part, fair part. You can copy it. This much explanation is required, and I have written everything over here. Done? If done, then we are done with the circle. Okay, just a moment. Yes. So we are done with this chapter. Okay. Now we'll be starting area related to circle. Okay. So yeah, let's start. Okay. So at first here you need to know what is the sector of the circle, what is the segment of the circle, which we have already done the discussion in the like introduction class. Again I'm telling you what is the sector and what is the segment, because here basically in every question we'll be finding the area of sector, area of segment. Okay, so first sector of the circle, sector. Okay, sector, we have done the discussion that if you are having an arc, okay, arc, you are having a specific any arc, then area bounded by this arc which I am highlighting and the radius is this radius and this radius, this much area is called sector of the circle. Okay, if we have to find the area of this sector, there is a specific formula we'll be using. This is called the sector of the circle. This region, this area is called the sector of the circle. Okay, since it is the smaller one, we'll be calling it minor sector, and the bigger one, already one more sector you can see over here, that another arc, this much arc is also giving us an area. This arc with again the same radiuses is giving us this area. This is called the major sector. Okay, so area of the circle's formula is, what is the formula for area of the circle?
Two pi r.
Area of the circle, 2 pi r is circumference, right Maha? Area is anyone? Area of the circle?
2 pi r square.
No.
Pi r square.
पाई आर स्क्वायर, सर्कल के एरिया का फॉर्मूला है पाई आर स्क्वायर.
Oh,
Okay,
yeah.
2 pi r is the circumference, that means perimeter. Okay, you know that circumference and perimeter is the same thing, right? So 2 pi r is the perimeter of the circle. Area is pi r square. Now this is the formula for area of the circle. Now if you understand the complete angle in a circle is 360 degree, right? Right? The total angle, if in the
Yeah.
same circle, if I'll try representing the complete angle, this complete angle is 360 degree. Of course, it is a complete angle, it is 360 degree. But while finding the area, suppose we want to find the area of this minor sector. Okay, suppose we want to find the area of this minor sector, that means this much only area we need to find. This much, whatever this angle is there, maybe that will be helpful or whatever, only this part's area we want to find. If I am writing that we want to find the area of minor sector, okay, that means the complete 360 degree we don't need, only this much angle can be helpful, right? Because it is falling in our actual minor sector, right? So what we will do, we will make a formula by ourselves. We will say that pi r square will give the total area. Okay, we don't need the total area, we just need this much area. Okay, that means maybe the angle is theta, so theta by 360. If we will do, we will get the fractional part, that this much is representing 1/4, 1/5, or whatever, 2/5 or 2/4, whatever it is representing, that much of area only we need. Am I making sense to all of you?
Yes.
Yeah.
Okay.
Yes.
This is how till now whenever you get the test paper, whenever you get the your exam sheet, this is how we mark the marks also, that you have got out of 20, you have got 10 marks, you have got 18 marks. That means the fraction, how much fraction, like from there you can also convert it in decimal percentage by just doing the multiplication with 100. So that fractional part I am trying to represent over here, that this fractional area we need to find, and from here we ended up getting the area of sectors formula. Okay, here I have written minor sector, but this is basically the formula for finding the area of the sector. So write it. Let me write this minor sector. Area of the sector's formula is whatever theta is maintained over there, that divided by 360 into pi r square, because that is the actual formula for area of the circle, that will give the total area. If you understood this one, then I'm giving one circle and the angles as well. Please find the area of the sector. We'll be discussing the segment and we'll be discussing the other terminologies as well. Find the area of the sector of a circle with radius 4 centimeter and angle of 30°. Please find the area of the sector.
Do you have to substitute pi?
Yeah, I'm giving over here that you can take pi as a 3.14. Please find it. Formula was theta by 360 into pi r square. Here theta is given 30°, r is also given. Please find it. Note down, no, theta is 30° and r is 4 centimeter. I'm just stopping the screen sharing. Theta is 30° and r is 4 centimeter. Today you will be able to give the assessment from circle, whatever assessment was left. Yes, what are you getting?
Ma'am, I have a class now. Can I leave?
Yeah.
I'm getting 4.15.
Okay, 4.15. Just a second, let me check. Yeah, we'll be getting some 4 point whatever. So yes, this is how we'll be finding the area of this minor sector. Since it
Ma'am,
says to find, yeah,
what will the unit?
what is?
The unit.
The unit is centimeter square. Okay, I have not written the unit. Yeah, centimeter is there, Maha. The unit of area is centimeter square. Any shapes area, be it circle, be it square, be it what if meter is given, meter is square. If centimeter is given, centimeter is square. If kilometer is given, kilometer is square. If feet is given, feet is square. Square will be there because you can understand square. R square was there. So centimeter into centimeter we had done. From there, centimeter square is coming, which we write as a square centimeter also, which we write as a square
Okay.
centimeter also. Both are same thing. However, for perimeter, we write only the centimeter. Okay, if you will be finding perimeter in any case, 2 pi r, you can understand only one r is there. So unit will be only centimeter. Okay, whenever we measure the perimeter of any shape, not the circle, okay, any shape, we are just measuring the distances. Okay, so we must be clear with area and perimeter. When I am drawing a shape, maybe like this, maybe like this, a random shape. Okay, and if we have to find the perimeter of this shape, that means all the distances from here to here, then from here to here, then from here to here, all the distances if we are having in hand, then we can add them all, and that will be the perimeter of this shape. However, if we have to find the area of this shape, that means this much, this complete, we will try finding what exactly is the region, this one. Okay,
Okay.
so yeah, this is how we'll be doing here. One more part was there which says find the area of the corresponding major sector also. So if we have to find the area of major sector, we are having two way. Either we will be finding the angle and then we'll be using the same formula, that is this is 30 degree. So of course the remaining will be 360 minus 30, 330. Okay, that angle we can use and same formula we can use and we can find the area of the major sector. Or maybe you can find area of the complete circle pi r square, and from there subtract the area which you are having in hand, 4 point whatever you have got, that area if you will subtract, you will end up getting the major sectors area. So either the formula by taking 330 degree, or subtract from the total circles area, just take it out, this